Hello students, I'm Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem and Facebook page, Chemistry the Mystery of Molecules. Today's topic of discussion is a very interesting MCQ. I request everyone please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now, the question. What is the major product of this reaction? This is actually an alcohol, cyclopentane ring and carboxylic acid. It is treated with K2Cr2O7 and heat. By the way, if you look at K2Cr2O7, this is actually a very strong oxidizing agent. Why? Because the chromium atom oxidation state is +6. Although you can say, sir, it's an argon electron configuration, it should be very stable because nearest noble gas electron configuration. But it is actually very reactive because very high deficiency of electron. +6 means very high electron deficiency. That's why it's a very strong oxidizing agent. And it can oxidize, by the way, primary alcohol into aldehyde and secondary alcohol into ketone. Now, if you allow the oxidation further, then this aldehyde could be oxidized further to corresponding carboxylic acid, but the oxidation of ketone is difficult under normal condition. If you want to achieve it, you need to provide vigorous condition, I mean high temperature, higher reaction type, concentrated reagent, etc. Why this is? Because during this oxidation, you need to make carbon-carbon bond, means ketone to touch further oxidation, you need to break carbon-carbon bond, which is very difficult compared to aldehyde case where a CH bond needs to be broken. So this is the main concept here. And if you produce beta keto carboxylic acid or beta keto acid or beta double bond carboxylic acid, such kind of molecule undergoes facile decarboxylation through 6-member cyclic transition state, means their decarboxylation is far more easier. So this is the main concept, and let's do the problem accordingly. So this is a secondary alcohol. Now it will be oxidized by potassium dichromate to corresponding ketone derivative, and the carboxylic acid will remain as it is. Now you may ask one question, that sir, why you are drawing this molecule in this way? This is because, student, now I am going to do decarboxylation because heating is provided. So in presence of heating, this decarboxylation takes place. What do I mean? So here this proton is abstracted by this bond. Now in some places ultimately they show this oxygen lone pair, but both are correct. It comes here, it opens up, come back, and this negative charge comes here. What it produces? It produces, this is OH, and here one negative charge, positive charge, plus carbon dioxide. And by the way, this positive negative charge actually combines and produce this double bond. This is nothing but, student, enol, and these undergo tautomerization instantly to produce corresponding keto derivative. Okay, so this is actually the overall reaction, and what it produces? Obviously cyclopentanone. So this is the right answer. Now if this question appears in your exam, how to solve it? Very quickly. First, dichromate, secondary alcohol, ketone, true, and it is a beta position. By the way, this is carboxylic acid is my main priority functional group. So this is alpha position, this is beta position, there is double bond. So obviously beta keto acid decarboxylation can take place very easily, and obviously heating is also provided. You see, one information I guess you have studied, that if you heat malonic acid, this one, so it also undergo decarboxylation and produces acetic acid. Same way, 6-member cyclic transition state resulted elimination, means carbon dioxide comes out from the reaction medium, equilibrium going in the forward direction, so you get it. By the way, here I shall not say try to apply any tricks, rather than remember this information, it will be helpful. So this is the overall discussion. Thanks for watching. See you in my next video.